Pierre is the commercial director for Spatialedge, and is going to present on AI and CX retail, AI in retail. Over to you, Pierre.
Awesome, thank you so much. Hello everyone. So I quickly want to take you guys through basically our view of AI in retail. And I know there's been a lot of hype, there's a lot of revenue that can be generated, a lot of costs that can be saved by the use of AI and machine learning in general. But before I actually do get started with that, let me tell you about how AI can help you lose 50 million Rand in a single month. So there is this company, a credit solution provider. They provide loans of different kinds to the consumers or the consumer group. So the consumers go to them, or the customers go to them, they take out the loans, and then they use those loans to obviously buy something like furniture, clothing, etc. So this company, being a credit solution provider or loan provider, they also have what we call a collections department. And this department's specific goal is if somebody has not paid within a specified period of time, within that month, for example, within 2-month grace period, then the collections department's purpose is to follow up with those people who haven't paid back yet and get them to pay back their money. Now, this can be quite a massive operation if you think about it. Some of you may know, some of you may be experiencing this, but you essentially have a small team that needs to collect or get money back from a large number of people. So there was a data scientist inside this company who developed a very, very useful and valuable model. This model, what it did was it could figure out in terms of all the customers that has not paid back in previous months, which ones you should be contacting, when you should be contacting them, and how you should be contacting them, so that you can essentially prioritize your list, and you make back, or you can easily spend your effort right to make back the money. Now, unfortunately, what happened 1 month is one of the upstream data sets essentially started failing. That error cascaded through the system, and the machine learning model that provided the results to the collections department didn't do so well in terms of the results, resulting in them losing about 50 million Rand worth of revenue that they could have made that month. Now, in essence, it was actually a little bit more than that, seeing all the cost of operating and trying to get back that money. But such are the impacts that could happen, especially when you're running very good machine learning models or very valuable machine learning models and systems of your organization, but you haven't taken the time yet to put all the practices and things in place. So I'll be chatting to you guys a little bit then actually about MLOps in retail, how you can essentially make sure that you can deploy machine learning models into production in a robust and efficient manner, in a way that if something does go wrong, you're able to obviously fix it in time. So all the different kinds of things that could potentially go wrong, I kind of made a little list here so I can go through them. We see these things happen on a monthly basis, and if you've got the right systems in place, they can be small mistakes that can be easily be fixed. If you don't, it might be a silent or an unknown error. But let me get started. So one of them, for example, is data changing. That could be the data sets themselves, or you need to reference different data set, or what in the industry is called data drift, as in you've got a specific feature or parameter that's used in one of the models that changes, the distribution changes over time. A good example of that would be, or maybe a simple example of that would be age as a variable, or the feature of the column age. And let's say you're an organization who are selling to teenagers, or your customers were teenagers at a point in time, and that might have changed over time to be elderly people, or people between the ages of 50 and 70. I know it's a bit of a strange example, but if you think about it, that kind of did happen with Facebook as the population changed from being teenagers and university students to an elderly population. So that kind of change can affect your data systems and your machine learning and AI systems over time. Data type changes, such as upstream operational systems changing the way that they work, It can have a very big or detrimental impact. Infrastructure failures can have an impact. Coding mistakes in the team itself, if there's not enough or good enough validation. Human error. A lot of companies are still also working with processes where there's a lot of humans in the loop. Basic things such as just working with Excel sheets or building out Excel sheets and trying to use that, in your machine learning models can cause potential issues. The problem of quick changes. So if a data team has a lot of pressure on them, or a development team, and then they want to quickly change something or roll something out because there's a feature that the business is really looking for, and the necessary validations and checks on automation is not in place, things can and sometimes do go wrong. Communication issues and insufficient testing and qualification of models. And probably the last one I want to mention here is, unknown and the silent failures. When things happen that you're not necessarily aware of, and then it has a very big or detrimental impact on your business a while later, which you could have stopped if you had metrics or monitoring in place. And I'd like to kind of leave you with a little bit of, do you know what is happening inside of your data teams, and are you aware that of all the failures are happening and how fast it's being resolved? So even though this might be a little bit anecdotal or sound anecdotal, there is a lot of evidence in the industry as well. For example, 87% of projects there's now artificial intelligence projects don't even reach production. A study done in 2019 by VentureBeat. 50% of AI projects tend to fail, which is quite large and highly impactful, taking into account that it took time and effort and cost to develop that model or that machine learning solution. And if it fails, you're also losing out on the potential opportunity cost if you have to redo it or build a different model. And then 51% of infrastructure can't scale properly. So if you build out those models and machine learning pipelines, you need to obviously make sure it can scale. And without having proper operations in place, it's almost impossible task. Okay, so maybe a good question is, why should you guys listen to me or to us here at Spatialedge? And the reason is we kind of going against this trend. So we've worked in telecommunications, retail, and financial industries. We've created a ton of value for different organizations inside these industries. We've operationalized more than 100 different use cases. Some of the things we're quite proud of is we're processing around 90 billion transactions per day, and that's, when you want to talk about big data, that's quite big data. And for reference, in 2020, WhatsApp processed about 100 billion messages. So it's quite close to the number of messages WhatsApp processes per day. We've also built out full data analytics or business decision applications inside the retail industry, helping people inside the organization, employers, to make better decisions by using machine learning models. And I've also worked in the financial industry. So in comparison now, we've actually been able to get 90% of the projects successfully operationalized that we work with. We've also been able to do a 7 times faster delivery. Now, again, to put that into context, it used to take us about 4 weeks to get a new data source operationalized, data source pulled in and into a feature store, transformed into feature store. These days, with the model ops capabilities that we've built in place and with the processes that we have, we're able to get a new data source from its raw state within about a day. And similarly, with getting a model from prototype into production, that used to take 4 to 6 months, and now we can do that in 2 weeks. And just a good example, last quarter, which is about 60 days, we were able to do 55 different models, which generates a lot of value for these organizations. So that's about almost a model a day, which is quite cool. And so for these organizations, obviously, we provide them with a 10 times return on their investment. But enough about that. Back to model operations. It's a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently, so that you can avoid massive failures when you go about creating these things. Some of the benefits this creates or gives you is it enables you to get your machine learning models and systems faster into the market. There's opportunities that come up. For example, now with in this conference, we're talking about customer engagement, building out and rolling out chatbots and these kinds of things. That can add tremendous value to your organization if you're able to do it, and obviously you can then keep up with your competitors. So with model operations in place, you're able to obviously roll this out, these kinds of things out a lot quicker, thereby capitalizing or not paying that opportunity cost. There's less failures and shorter downtime associated with it, because you are monitoring the systems and you're able to automate a lot of the deployment issues that may happen if you don't do it. It's a lot more easy to maintain and create sustainable solutions. So what we've also seen a lot is data science teams, they start building models, and they build some very successful models, which they then end up owning and operating. But without the automation in place, they start to it becomes a maintenance burden for them, which takes them away from developing new models. And ultimately, this means if you're able to implement this correctly, it will create more value for your business. Now, there are quite a bit of components that we could deep dive into in terms of model operations. I don't have too much time to go into all of them, I'm trying to actually give you the idea, or sell you on the idea that you should obviously implement this inside your organization, but at the same breath, I can't cop out from also explaining a little bit more about what it is behind it. So this first diagram here on the left is essentially showing the incremental development process that you can use inside of the model operations workflow. It's in the words incremental, meaning that there's design, model development, and operation step, but those steps are continuously intertwined. And if you do it, for example, in an agile fashion, sprint by sprint, you can start with your design, planning out the model, getting the requirements together, etc. Move on to the model development of the first version of the model, getting that validation, some of that testing in place, and then doing a minimal deployment to gather some feedback and see how your predictions are performing in the real world. And then you go, again, as you learn them from the real world, see how it's impacting your customers or your users, you can then go back to designing, adding more features, doing further model and feature development so you can improve the system. I also do quickly want to point out that with model there was in the development world, there's a concept called Devops, which has been developed over the past 20 years, which allows development teams to efficiently build out new applications. Now with MLOps or model operations, the data becomes a significant component that is added to this equation, which means that you've got a multitude of different data sources, which means a ton of different dependencies that the data team needs to be aware of and manage to be able to build out these different models. And then with that, obviously, a lot more new components. And some of the new components are things like a data science experiment area, tracking the different versions or version control of your data sources, version controlling your models, your model artifacts, and also then building out specific capabilities in terms of data engineering, machine learning engineering, etc. The AI and MLOps landscape is also huge and massive, so it's not that easy just finding a specific vendor who can just help you with everything. And a lot of the tools and components we've seen with the clients that we've worked with doesn't necessarily come with these things baked in. So my key takeaways for you today are key success factors that I think will help you guys. The first one is basically to be able to implement MLOps inside of your organization, you do need the right skills for the right roles. In other words, some data scientists may be able to build operational systems quite well if they've got a strong software engineering background, but generally they may have more of a statistical background, operations research background. So you'd want to get a machine learning engineer, a software developer, these kinds of different roles, specifically a data engineer as part of the team. So putting the right skills in for the right role so they can build out these systems for you. You want to obviously have a multifunctional team. You want to put that team together so that they can complement each other. And then you also want to be able to build, or you want to start with building minimum viable model ops capabilities. The reason behind that is a lot of the principles and processes around model ops can be done with the systems you currently have, and should definitely be done with some of the systems that's available. And by figuring out what the most important thing is to do next, allows you to then understand your own environment in terms of what you need, and it'll also, I want to say, protect you from going out and buying a solution that may not be beneficial exactly what you require. If you look at, there's about 5 key principles to model operations. The first one is testing. The second one's monitoring. Then there's deployment, reproducibility. And I just want to leave you guys also with that. Some of those things are not necessary early on. For example, automated testing, validation, monitoring, in my opinion, is critical to get right, especially with early models, so you can understand, so firstly, that you can test the system, second, that you can understand what is happening in terms of a business impact, creating and monitoring those business metrics, as well as the model metrics themselves, so that when something now actually does go wrong, you're able to quickly resolve or fix it. And then something like deployment, if you can implement automated deployment early, that'll be great. If you're not able to do that or implement continuous training, automated training early on, that will be cool. But if you're not able to do that, I'd rather just focus on the automated testing, validation, monitoring first, and then you can build out the capabilities and get to the other parts later. And then if you are thinking, we really should be doing this, we want to get this model operations done inside of our systems, I would also preach balancing the ambitions with the patience. So that meaning that it is going to take time getting these capabilities built, especially if you're chasing use cases and trying to get value out of your models. So just be aware that it will take some time. Of course, there is also the alternative of, just contact Spatialedge to help you with some of these things. But yeah, it's just a little bit of a joke. What kind of joke, no joke situation. So just a quick thing about us at Spatialedge, we are specialist data and AI professionals. We build and augment data and AI teams. We've got centers of excellence for data and AI, and we build out we've got different technologies and platforms that we provide to our customers. We help them with data and AI transformation. And lastly, we build these decision applications that essentially captures the end-to-end, it's the end-to-end life cycle to get into a machine learning model, but then a decision application that can make use of that machine learning model inside of your organization. If you're interested in any more information, please do visit our website or contact me at sales@spatialedge.co.za. Cool. Now let me know if you guys have any questions.
Thank you, Pierre. Surely there is no easy way to analyze unstructured data. I liked your presentation and the tools that are at hand for the organizations to use and move forward. The data and the insights, they really provide value in terms of how organization can move forward in terms of artificial intelligence. A very insightful and well structured presentation, Pierre. Thank you very much.
Thank you, Benson. I actually also see there's a question came up from Dino. So how long have you guys been around, and do you offer consulting services with the platform and or platforms separately? So we've actually been around since 2013, 2014, but the company Spatialedge itself has been through many different iterations. We only started providing consulting from end of 2016, beginning 2017. We don't provide it separately. We try and focus. We've got a lot of people with a lot of experience in developing and building out these applications, we do have, I almost want to call it a glue layer that we provide on top of, well-known platforms such as your Spark environment, or on top of GCP or AWS, where we still use the underlying components for most things, but then we add that layer to speed up the processes for the different organizations, and then help them with getting to the goal of delivering a AI solution inside that organization. I hope that answers the question, and I think those are all the different questions. Cool. If you do have any other questions, please do feel free to reach out.
Thank you, Pierre, for reiterating again that we need to focus more on action and to implement, and we have to balance ambition and patience, select the right skills for the right roles, and maintain well-balanced remote functioning teams. Those are some of the points that I picked, and I think going forward, if we understand that for artificial intelligence to work so well, it will always need people, I think that will be a very good approach, and you will be able to achieve much better things. The next session that we are entering into, it will be a panel session after the break. Let's meet after the 1 minute break. Once again, thank you, Pierre, for the presentation. Thank you very much.
Awesome. Thank you so much. Cheers, guys.